Postulates and theorems. A corollary is sort of like an addition. It's basically an idea that follows the theorem. Sort of like if your theorem is that you're going to go to the movies, you're going to go to the movie theater tonight, the corollary is you're going to buy popcorn. You know, it follows. Like if you go to the movie theater, I mean, how many people go to the movie theater and don't buy popcorn? It's probably few and far. Okay, but it's few and far between. So generally speaking, or okay, snacks of some sort. First one is that the acute angles of a right triangle are complementary. This means they equal 90 degrees when you add them up. And that makes sense. If an entire triangle is 180 and you make a right triangle, 90 degrees is one angle. The other two have to add up to 90 degrees. See, there's something like that sort of like makes sense from what we know about triangles. And the other one is that there can be at most one obtuse triangle, or one obtuse angle in a triangle. And that also makes sense because a triangle adds up to 180. An obtuse angle is greater than 90. You've got three angles. You can't have two of them greater than 90 and still equal 180. So these are just things that they wrote them down officially, but they're kind of like, well, okay, yeah, that makes sense. Right? So 190 means this is 90. So if this is 90, then these two add up to 90. So angle 1 is 90 minus 63, which would be 27. And if this is 27 and this whole thing is 90, that would make this 63. I already figured out that 90 minus 63 is 27, so 90 minus 27 is 63. Does that make sense? So then if this is 90 and this is 63, well, we already know that these two have to add up to 90, and we already know that 90 minus 63 is 27. So congruent triangles. And okay, congruent polygons occur when all parts of one polygon are congruent to the corresponding parts of another polygon. Okay, and the parts are the sides and the angles. Okay, so congruent polygons have to be the same polygon, so you have to have two pentagons. You can't have a pentagon congruent to a rectangle. So they're the same sides and same angles, and the corresponding parts are the matching parts. So in the same position. So you know how we had the corresponding angles in the parallel lines with the transversal? They were the angles that were in the same position. The corresponding parts are going to be in the same position. Okay, so we have an official definition which states that two polygons are congruent if and only if. This is called a biconditional statement. You have to have both conditions for it to be true. Both conditions have to be true. Oh, I didn't mean to do that way. Sorry, hold on, let me fix that. And only if, which you don't have to write out anymore. If and only if in math is abbreviated as if with an extra F. If and only if. Their corresponding parts are are congruent. Okay, so that means that if these two triangles are going to be congruent, I would have to look at the rotation and everything. So AB would have to be congruent to PQ. BC would have to be congruent to QR. AC has to be congruent to PR. And angle A has to be congruent to angle P. Angle B has to be congruent to angle Q. And angle R has to be congruent to angle C. So all the sides have to be the same length. All the angles have to be the same measure. With the triangle, there are some things that can occur to where you don't have to have all three sides and all three angles, so you don't have to have all 6 things. We can have 3 of them. And if we have the right 3 of them, then we can say that the triangles are congruent. Because what will happen is if you have these 3, it means the other 3 also exist. So, but what we have is that when you have the congruent polygons, all the sides are the same, all the angles are the same. And it's important that the letters are written in the same order. I mean, it's really important. So I have A is congruent to P. So when I write this out, the letters have to be in the same order. So A, B, C, P, Q, R. Okay? Because A is congruent to P, B is congruent to Q, and C is congruent to R. They have to go in the same order. If you write them in the wrong order, it's a false statement. So I can't say like A, B, C is congruent to R, Q, P or something, because they're not in the right order. So you can't do this. They have to be in the same order. That's really important. And then we'll write the congruent statement. So you have to have 3 sides, 3 angles. Okay? And it doesn't matter which order you list them when you're just saying which are congruent to which, just so long as you have the right ones congruent to each other. Besides, yeah, so I can say, okay, J is congruent to T because they have the same number of loops. P is congruent to V, angle V, sorry. And then angle L is congruent to angle S. Then I need to make sure the sides are the same. JP is congruent to TV. PL is congruent to VS. And then LJ is congruent to ST. Then what matters with the order is I list the first triangle and I can put that in any order I want. JPL, LPJ, LJP, PLJ, whatever. That part doesn't matter. The first triangle I can put in any order I want. It's the second triangle that I didn't have to match. So since angle J was first, angle T has to be first. Angle P, so angle V, angle L, so angle S. So that's the part where you have to be careful, is when you're doing that second triangle to make sure you match the congruent letters to each other. They're in the same order. So angle 3 is the same as EFD, and angle 4 is the same as GFD. And then angle G and E, we'll just call those G and E. And then DF is congruent to itself. This has a special name, actually. This is called the reflexive property, which will come up later. And the reflexive property is just when anything is equal to or congruent to itself. It's like a reflection, reflexive, reflection. And then DE is the same as DG, and EF and GF are the same. And so then I said DEF, so I had to say DGF. Any questions on that? To find missing values. So congruent parts are equal to each other. Okay, so I have ABC is congruent to FDE. The first step is to mark all the congruent parts. So angle A is congruent to angle F, and I know this because they're in the same position. Angle B is congruent to angle D, and those are already marked, but I'm just going to put my own marks on there. And then angle C is congruent to angle E. Okay. Right now we're just doing angles, so we don't have to label the sides, but if you wanted to label the sides, you could. Okay. So I need to find the value of x. I know that angle F and angle A are equal. I don't know what angle A is yet, but I can find it by subtracting from 180. So I'll do 180 minus 108 minus 48. And that tells me that angle A is 24. So angle A is 24, which means that angle F is also 24. So far, follow? Okay. So then I'm going to set 2x minus y equal to 24, but I can't solve that yet. But I have that this angle here is y. Angle D and angle B are the same, so if this is 48, that makes this 48. That's the answer to number 4 right there. Okay. So now I know that that's 48. I can plug it in for the y. Add 48 to both sides. And I'll get that 2x is equal to 72. Divide both sides by 2, and I get that x is 36. Then we have this theorem, the third angle theorem, which tells us if two angles in one triangle are congruent to two angles of a second triangle, well, then the third angles are also congruent. And it makes sense if you think about it, because triangles all add up to 180. So if two are the same in here and two are the same over here, you'd subtract them from 180. The third one would be the same. Okay. So what we have for this problem is if angle PNQ, so PNQ, that's this angle right here, is congruent to angle RST. That's this angle here. These are both 90. Okay. NPQ is 40. What's SRT? Well, these two angles are congruent to these two angles. That means that this angle is going to be the same as this angle. Does that make sense? Because since this one's the same and this one's the same, these are the same. So if this is 40, this is 40. And if we had to, we could find this angle. We would subtract from 90 and we'd get 50. And since that one's 50, this one would be 50. So we could find them all given 1.
So we knew it was the same because of how it was written.
Because, yeah, what we had, here, let me go back through it. Okay. NPQ, so that's NPQ, that's this one, is the same as RST. So that's that one. Okay. These are both right triangles, or right angles, so they're congruent. And because 2 angles in the triangles are congruent, that makes the third angle congruent. NPQ. I labeled it wrong the first time, actually, now that I've just caught myself.
I was wondering.
Yeah, I sure did. I labeled it wrong the first time. Sorry about that. Sorry. But because these 2 were congruent, and these 2 are congruent, that forces these 2 to be congruent. And then once we know that NPQ is 40, we know that this one's 40. 40 and 9, we have a 90, so these 2 are 90. So that makes this 50, and this is 50. Sorry about that. I just kind of went over this one with you, the reflexive property. Triangle ABC is congruent to itself. The reflexive property of congruence is always something equal to itself. Okay. The symmetric property, okay, tells me that if triangle ABC is congruent to triangle EFG, then triangle EFG is congruent to triangle ABC. What the reflexive property does is it flips around the equal sign. Or congruent sign. It just changes the order around the equal. And then you have the transitive property that tells us if triangle ABC is congruent to triangle EFG and triangle EFG is congruent to triangle JKL, then triangle ABC is congruent to triangle JKL. Okay. What transitive property does is you go through this middleman. You'll always see a statement in the middle that is something and itself. Think of it like if $1 equals 4/4 and 4/4 equals 10 dimes, then you have $1 equals 10 dimes. So you can like make change without doing the quarters in between. So you can go straight from the dollar to the dimes kind of thing. There's like a middleman in there that you cut through. And you take him out. So whenever you see this where you have something equals something and itself, this matches, and then equals something else, the ending statement took that part in the middle out. And that's how you'll know it's transitive. It's called transitions because you're transitive because you're transitioning through something else, but then you take it away. Three major methods for writing proofs. There's a paragraph proof, a flow proof, and a 2-column proof. And the 2-column proof is probably the most widely used. And that's what we're going to use in this class. We're not going to do the paragraphs or the flow. Okay. In a 2-column proof, it's called that because you have 2 columns. You have statements and reasons. And the reason you have to do this, you can't have any statement without something to back it up. Like, I could say the sky is blue over here, but I have to have something over here that proves it's blue, like due to the picture I saw or something. You know, like there has to be some sort of proof. Okay. You always want a picture. If the picture is not provided for you, draw it, because the pictures help immensely with the proofs. Okay, so I'm given that AB is congruent to CB. So AB and CB are the same. Anything that you're given gets written down and the reason is given. AD is congruent to CD. That was also given. I have that angle ABD is congruent to CBD. That was given. And finally, I have excuse me, ADB is congruent to CDB. That's given. All right. I need to prove that triangle ABD is congruent to triangle CBD. That's what I'm trying to get to. This is where we're going. That has to be our last statement. I have two sides and two angles. I need the third side and the third angle. Well, this side is itself. And you can always say something is itself. So now I have the three sides. All I need left are these two angles, angle A and angle C. And I've got that from that third angle theorem. Okay, my third angles theorem said that if two angles in a triangle are congruent, then the third angle is congruent. And you don't have to write that out. You can just write third angles theorem. If you want to write it out, you can, but you don't have to. So now I have all three angles and all three sides. So I can say triangle ABD is congruent to triangle CBD. And the reason I can say this is because of the definition of congruent polygons. And the definition of congruent polygons is that all the sides and all the angles are congruent. When we get into proofs, the things that are going to go in this reason column are definitions, theorems, postulates, corollaries, but mostly definitions, theorems, and postulates. And then you've got properties like addition, subtraction, reflexive. And we'll, like I said, we'll go through this more in depth in term B next, starting next week. I just want you to see the process so it's not so like, oh my God, what is that? Okay. Everybody got this one written down? All right. Let's look on the page 48. And this one, they don't give us a picture. So we're going to draw one. Okay, I have to try to prove that triangle PQS is congruent to triangle RQS. They're sharing a side QS. Do you see that? So I've got some side Q and S. And then I've got some point P and some point R. That's how I knew how to draw that picture, was because these two things were the same in both, so that told me they're sharing that side. And maybe it doesn't look exactly like this, but it'll look something like that. Okay. Then I make my columns. Angle P is congruent to angle R. That's given. PSQ is congruent to RSQ. That's given. PQ is congruent to RQ. That's given. And then PS is congruent to RS. That's given. This proof is exactly like the last one. So who can tell me the next line? I got to find one more side and one more angle.
It would be
QS. Yeah, QS. And if anything is ever congruent to itself, it's reflexive. Okay, and then I just need that last angle. If you want, you can number them so you don't have to worry about the letters. And I want these two things to be congruent. How do I know they're congruent? Same theorem, the third angle one. Because I had two congruent, that means the third's congruent. And then, we'll just continue over here. Triangle PQS is congruent to triangle RQS by definition of congruent polygons. And again, at this point, I'm not really trying to teach you how to write the proof. I'm just trying to get you familiar with what they look like. When we get into the next section and we're actually